Okay, husband's done doing his work in the kitchen, so hopefully it's a little quieter. I like to work on my kitchen island, which he would probably say you should probably not do that. Anyways, let's get started. Aside. Last thing is, how do I compute r squared? If you only wanted to know how to compute sum squared error, you can start the last video where I described sum squared error earlier. There are formulas that you should know in the fact sheet, but I also recommend, if you're not a formula person, just to know how to set up these columns. What you'll do to do r squared, so let's calculate r squared right now. It's so the thing about sum squared error is sum squared error, you can look at the sum squared error of one model and another model and then compare the two. If the sum squared error has gone down, your second model is going to be better than the first. So it's a way to compare models. It's just taking the error and then looking at the raw error. But what if you wanted to just know immediately, is this a good fit or not a good fit? You want to calculate, in that case, r squared. It's not the end all be all. I just want to remind you all that it's in the reading what the limitations are. But here I'm just going to show you how to calculate it. What you need is one additional column. And so I'm going to see if I can copy and paste this below this thing right here. Copy and paste this guy. And instead of what I have here, I already have error and error squared. Ooh, I didn't get the whole table. Let me do that again. So sloppy. Let's do that paste. Still not doing everything, but I'll just fill in these values. So I'm really actually now going to look at just a few columns. Now I'm going to look at something called sum squared total. And so what that is, so we have 0 here. Let's do this. I'm going to make it easier to do this. So I'm going to just put an additional, let's see if I could do this like this. Oh, it's still doing that whole thing. All right, so we're just going to do it old school and just put another column. So I'm going to put in an extra column here. It's called sum squared total. And what that is, it's a taking these original actual values and I'm going to square them all. So, for example, I'm going to take 9.6 and square it. And I get 92.16. And then I'm going to take 35.3 and square that. And I get 1,246.09. Take 61, the numbers are going to get big. 61.2 and square it. And I get 3,745.44. And then I'm going to take that last value and square it, which is 90.1, and then square that. And I get 8,118.01. So that's a sum squared total. This is just the sum squared total. This is the square total, so it's not sum squared total. Let me erase that. The sum squared total is the sum of all these guys. So I'm going to go over here and compute sum squared total is these guys all added up. You guys are faster at doing all these calculations on your calculator. I wouldn't do it like this on a test. hopefully on a test you don't have as many here. Even 4 is a lot. But let's go and add all these guys up. 1246.09 plus 3745.44 plus 8118.01. And this old lady has this huge number like that. And r squared is going to be 1 minus SSE divided by SST. Okay, so I'm going to have to take that and just crank it out because I erased everything off my calculator. So I get SSE was 11.56. I think I had an error here. Plus 0.4, so this should be 11.6. So 11.6, not 11.56. Hopefully you caught that in the other video. So when I divide that, I get 11.1 minus, you have to remember your parentheses here, 11.56 or 0.6, I keep wanting to say 5.6, divided by 13201.70. It should be gigantically small. What's interesting is this is not even easy for me to calculate on a calculator. It's a pain in the behind. But I didn't want to actually put anything in Excel, even if I'm tempted, because you do have to calculate them by hand on a test. So give yourself time. I get 0.99916. So what that's telling me is that 99% of the variance in the data is explained by my model. And it's a really good model because it was synthetic data and it was made up to be perfect. So that's why. So that's how you calculate r squared.